Before I can actually start with my presentation, I need to introduce two of my friends who came tonight, especially for this show with me from Geneva. Well, here they are. They're hiding a little bit. It's the electron and the positron. The electron is an elementary particle. It has a certain number of properties. Its size, its shape, its weight, and its smell. The electron, together with the proton and the neutron, forms an atom. Atoms can combine to form molecules. Molecules can combine to form cells. And cells, well, they can combine to form an entire human body. Which means that actually we have electrons everywhere. That guy is a positron. The positron has the same size, shape, weight, and smell as the electron. The only difference is that that one has a negative charge, and this one has positive charge. Now, actually, the positron is an anti-electron. It's antimatter. Now, what happens when antimatter and matter meet? Well, it's an explosion of energy, and they transform into two identical particles called the gammas. Now, those two gammas, they don't want to stay together, so they separate along a straight line. Now, you probably wonder what that has to do with medicine. Well, in nuclear medicine, we are able to generate drugs, so-called tracers, that can precisely identify cancer cells in the body. These drugs can be made as radioactive tracers, which means that they keep emitting positrons for a certain amount of time after they were generated. If I give this drug to the patient, it's going to look for the cell, it will stay there, and it will keep emitting positrons. And these positrons, obviously, will look for the closest electron. So what's going to happen? Positron, electron, they meet, annihilation. Two gammas leave the body along a straight line. I can put a very specific camera, called a positron emission tomograph, around my patient that is able to detect those gammas. And every time I see two gammas at the same time, I know there's cancer along the line. Now, if I keep doing this for a few minutes, I'll have several such lines. And those lines, they all meet in one specific point, the point where the cancer is hiding. Now, you know how it's possible to use antimatter, positrons, in positron emission tomography to find cancer in the case of patients where classic techniques like X-ray, ultrasound, or MRI were not conclusive for a final diagnosis. Thank you.